Hi guys, I hope you are doing great so far. In this video, we will explore nested types. Nested types allows us to organize related types within each other so that our code is more modular, readable, and easy to maintain. So let's get started. So we'll start with what nested types are. That is, when it comes to enum structures and classes, these are the three main types we have in Swift. If we can declare a structure inside an enum, that basically means we are nesting structure inside an enum, and that is called nested type. We will see the different types of nesting. That is, we'll explore all the combinations. That is, what all types can be nested in what all types. And just to give a brief, all the combinations are possible when it comes to the three types, that is enum, structure, and classes. And these are the only three types we have in Swift. Now, we will see examples of each nested type as well. Let's get started. Here I will mention the nodes and then we will start exploring one by one. Now here we will start with the nested types. What is it possible in Swift? And a note for us to remember it, why exactly we use it and why it makes logical sense to nest this type inside another type. So we will see enums and we will see if we can give enum inside enum and structure inside enum, classes inside enum. So all of the combinations are possible. We will start with enum and then we will look at structure. So enum inside structure, structure inside structure, and class inside structure. Then we will look at the examples of classes where enum is declared inside class, structure is declared inside class, and class inside class. Now, before we look at examples, we should understand that we have to have a logical sense behind using nested types. And moreover, on top level, it is all there to just module our code, structure our code so that the readability increases and it is easier for us to maintain for sure. And when exactly in what use case we should use each of these case, that we will see in notes when we are done with looking at the examples. So here, let's see enum inside enum. So enum inside enum we use when we are having errors. We want to create a custom type for error and we want a nested enum which will work as a type for some property or for some case. Now I have a enum ATM and I have operational and error two cases. This is a normal case, but this is a type enum. It has an associated type error, which is also an enum, and we are keeping enum inside this enum here, that is error. It has three values: insufficient funds, invalid pin, out of service. Now, of course, we can copy this and give it outside. But when we are sure that this enum is going to be associated or tightly coupled with enum ATM, we can declare it inside itself so that the scope of this error enum will be inside the enum ATM only. And here I'm using ATM.error, which is calling this, and this associated type is expecting a value of type error. So here I'm giving dot insufficient funds, which is one of the case of error. That's it. Now based on this, I'm writing a switch case here where we check if it's operational or error. If it's an error, I will capture that associated value which we passed into a let constant here and we'll print it. If it's operational, I will print ATM is operational. Let's run it. And it gives us ATM error insufficient funds. Now let's look at the second one. Now this can be used for related states or related errors. Since in this example we can see an error is related, so we can nest it inside ATM and we can use it for states as well. Now structure inside enum is used when you want to associate a value type inside enum. So structure is a value type. Let's say an example. So in this example we have an enum shape. It has rectangle and circle two cases. Now here in rectangle we last time we have passed error. Now here we can pass a whole structure type as well as associated type, and in dimensions we have width and height. So I'm using shape dot rectangle and giving it the value of type, the associated type, which is dimensions. So I'm saying shapes dot dimensions, some values to width and height. That will give me the case rectangle. I'm just printing it. Let's run this. I will comment it and it gives us the value that is shape.dimension. Let's look at the third example. Classes inside enum. Now when you want to have reference types, that is class inside enum, in the end we'll come to the nodes and we'll go through the nodes then. Also I will mention it here. So I've mentioned here it is used to encapsulate associated type. Now in this example we have the enum and inside that we have the class timer. We have three cases, that is red, green, yellow. All of them has the associated type timer. The timer has a variable stored property duration of type integer and an initializer for that. Here I am creating traffic lights enum dot timer and giving it a duration so that I get an instance of timer, that is the class. Once I have the instance, here I am accessing the value dot red, that is the case of enum, and giving it the value to the associated type that is it is expecting, which is the timer. And then we're storing it and just printing timer dot duration. Let's run this. I will comment it and it gives us red light duration 30, which is the duration 30 of the timer. Now it is useful for reference types associated with enums. Let's take a look at the next one. Now it is used to represent a specific option or states. I will mention it here. Now we have a structure order and inside that we have enum status. Now because structure order has ID status, now status is going to be of type enum. Now this enum, again we can declare it outside like this. But since it is associated tightly with the structure order and it will be in use with only structure order, then we can nest it here like this. And the scope of enum will be up to inside the structure only. And when we will access this property, here I'm creating the instance of structure, giving it some value. And when it comes to status, I'm giving the value dot pending, which is one of the status. And we are printing ID and status. Let's run it. I will comment this. And it gives us order 101 is pending. Now let's take a look at the next one. Structure inside structure. Now it is used to create a hierarchy of structures. In this structure player, we have a structure inventory. Now the player structure has name, inventory. Name is of type string, but inventory of type inventory. So we have a type structure here, which will have items and coins. And here we are creating the instance, giving name a value and inventory. And here we are just passing the instance of inventory. And we are just printing the name and inventory coins. Let's run it. I will comment it. It says hero has 100 coins. Now, if you want to extend this hierarchy, that is, you want to create more structures, name could be of type really name, inside which we will take first name, last name. We can do that as well. So it really helps when it comes to you creating the hierarchy of types, nested types. And now we can move forward to the next one, that is class inside a structure. So when you want to have a reference type like class inside a structure, we go with this nested type. So structure can contain classes for reference types. So here we have a structure document. Inside that we have the class editor. We have two properties, title and error, inside the structure, and the editor is of type reference type, which is editor. In class we have a variable stored property content and an initializer for that. Now when it comes to document dot editor, we are creating a reference of document dot editor, which is basically creating reference of editor, giving it some values. It will actually access the designated initializer here and will return us the editor reference. And we are just passing, when we are creating document object, we are just passing it to the editor. In title we have my document, and we are just printing the title and editor content. Let's run it. It says my document hello world. So a document will always have an editor, and since the editor is associated with a particular document, we can have a nested type for that. Let's move on to the next one. It is used for defining specific states inside the class. So here we have a class vehicle, and inside that we have the enum type. The type is going to be the type for a variable stored property of the class. And we have a designated initializer for the vehicle class. Inside the type, we have car, bike, truck, three cases. When we create the object of vehicle, we assign the type one of the values of enum, and then we will print it. So let's try running it. Now it says if this name is unavoidable, use backtricks to escape it. So I'm gonna just change this name to type 1. And here as well. And it gives us vehicle type car. Since type keyword is actually reserved, we have to use some other name for our enum. Let's move on to the 8th, that is the structure inside class. So the classes can contain the value type as nested inside classes. Let's see one example for it. We have a class house and a structure room as nested type, or to be specific, nested value type. The class house has the variable name rooms and a designated initializer for it. The rooms is of array of type room, and the room has name and size. When we create a house object, we will pass it the array of rooms. Here we are just passing one value, which is room, and creating the room with the living room as the name and 20.5 as the size, and we are just printing it. Let's try running it. I will comment the previous code, and it gives us dream home has a living room. Now let's move on to the last one, that is classes inside classes. So when you want to capture a reference type inside a class, we can go for it. This will help us to model the hierarchy. So we have a class school. Inside that we can declare a class student. Now the school class has two properties, name and students. Students is an array of student. So here we are having a nested class student, and inside that we have name, grade, and a designated initializer for it. We are having an initializer for the class school as well. Here I will create the objects. So we have a student object, and school.student is basically we creating a student, and we can create multiple student and pass it as the array of student to the property student of school. And we are just accessing school to print its name and the name of student. Let's run it. It gives us Greenwood High has a student named Alice. I will comment the previous. And that is all there is when it comes to the combinations of the types. What all types we can actually nest. So now let's talk about when exactly, specifically, each of them is useful. When it comes to enum inside enum, when we have error or state logic, to improve the readability or to organize it more, we can go for that. When it comes to structure inside a structure, when you have a structure and you want to encapsulate this related data with the enum to increase the modularity, basically, that's when we just go with structure inside the enum. Talking about classes inside enum, it provides a shared state or behavior across enum cases, which is useful for complex logic. When it comes to the classes, you can use them to write the complex logic and then associate it or basically use it as a nested type inside enum so that it is associated only with that particular enum. Talking about structures, enums are again basically just to handle the states and the errors which are associated or have scope only inside the structure. Then we go with enum inside structure. Now when we talk about structure inside structure, it improves the encapsulation of subcomponents. So when it comes to you creating the hierarchy of the structures for, let's say, the conversion of the JSON data into the local model, so we need a, a complex hierarchical nested structure. That is when we can use value type and it will be associated with another value type. So when we talk about classes inside structure, it helps us to share the mutable state or reference semantics within the value type structure. Now, when we talk about enum inside classes, it helps us to tie up the associated related type, that is associated enum, associated type enum, named associated type enum. Basically, all the types of enum that we can tie to a class and keep its scope within the class itself. So when it comes to structure inside class, we can go with it when we want to encapsulate the structure and we don't want to deal with a lot of reference semantic. Now classes inside classes, it suppose again, now classes inside classes will be used for modeling and more complex real world operations. If you have that, you can give it a class and keep it as a nested type inside another class. And that is all. I hope you find this video informative, and be sure to use nested type only when it makes sense, and go with structure inside class and class inside class only after giving it a thought. If you don't want to deal with reference or reference semantics, then you can go accordingly. But these are the few things that we should keep in mind when we are deciding whether we are creating a hierarchy of some model, or we need it for some logical sense. That is, we have a couple of things tied up for this particular class or for this particular enum or structure. Then we go ahead and associate that, tightly couple that with that particular type. And that's it. I will see you in the next.